Okay, welcome again at the second session this week. And for this session, I've prepared section 7.4. That means this is our last section in this week. Theoretically, we have one more section, 7.5, but 7.5 is just a summary of integration, which probably will be good to include this, which I will do most likely next week for the midterm review. Okay? That means, first of all, before I start, I'm really happy with the discussion board. I really liked your asking a question, some students answering a question. Great. That's how supposed to like the interaction should look like at the online classes, the distance learning. That means it's really good. Of course, I'm trying also to answer some questions, but I always wait a little bit and I like to see your answers, your participations. It's great. Oh, we can hear something. Can you please mute the microphone? Whoever is, and switch off the video. David, yes. Thank you. Okay, that means discussion board is really good. I like it. One more thing, the examity next week, the midterm test will be open. Of course, we will still have a review session, probably Tuesday and Wednesday, because the midterm test will be open, I believe, Thursday, and will be due Monday, as the same way like the weekly quizzes. That means during that window time, you can book the appointment on Examity, and I saw almost everybody had a time slot. That means be quick, because when you wait until last minute, you may not have the time. You may not get the time before Monday midnight. And that's actually the due date for the midterm. Okay, because the midterm test is the proctor test. Okay, that means you will still take on Canvas, but you will go through different system. You will go through the Examity, okay? Because they will proctor you. They will check. Like they will check your desk, they will check, you have to have the camera, of course, they will check like everything. You probably read all of the information. Okay, that's everything from me. Do you have some quick questions, admin questions before we start? If not, I can start. Okay, that means I also got on the discussions, somebody asked me if I can solve few integrals from yesterday's session. That means maybe I can wait at the end, okay? I will introduce you the new techniques of integration, and then I can, because I did copy few integrals, I don't know if that's the integral that you were talking about, but I can still solve some integrals which involves the trigonometric substitution, which was the topic from yesterday. Okay, that means the last technique that we have to know from chapter 7 is integration of rational function. And the integration of rational function, we will, the technique that we will apply, we call partial fraction decomposition. Okay, that means let's see what I have. Oh. Hang on, No, okay, I'm just trying to work with my slides. Okay, that means that just what I said. Having a rational function, okay? A rational function could be proper or could be improper. That means first of all, we have to identify a proper or improper rational function. It's similar to proper or improper fractions. Okay? And having a proper rational function, we will like divide it, we will change, we will rewrite as an addition, like a sum, addition or subtraction of partial fractions. Partial fractions means like a simple small fractions. Okay? Before I start doing this, we probably already using some of the basic rational functions, and we know how to integrate them. That means, for example, 1 over x. 1 over x is the rational function, because rational function we can recognize as a ratio of two polynomials, two things, 1 over x, natural log of x. We also know this one, 1 over x, just 1x plus or minus a, it's ln of x plus or minus a. We know this one from the inverse trig function, 1 over x squared plus 1, quantity squared plus 1 is inverse tangent of x, of that quantity. And this one is kind of like the fourth one. Let me put 1, 2, 3, 4. Number 4 is the like a chain rule or U substitution, I can say, is the more complex, more compound form of number 3. And as we can see, we have quantity squared plus 1, and this is inverse tangent of that quantity. But what we have to see the derivative, because if I will let u to be f of x, I have to have f prime of x dx for du. That means 3 and 4 are the same thing, and I also have one more, which actually 1 and 5 are the same thing. And that means 5 is the compound form of number 1. Ln of the denominator, we can see ln of f of x, but if I will let u to be f of x, I need the derivative to be cancelled out. Okay, that means just a few simple rational functions, and all of them are the proper rational functions. That means they are relatively easy to integrate. And I would even say they are like, this is just a partial fraction. They are so simple, we can't rewrite. We can't rewrite further. That's the reason that we do have kind of like direct antiderivatives. Okay, but let's look at the more complex rational functions. Okay, that's what we will do. I will take addition of two fractions or two rational functions, and they are simple, okay? And which we will call partial fractions. That means they are really simple. 2 over x minus 1 plus 1 over x plus 2. Okay? And what we will do, I will try to add them together, okay? Which probably we all remember the algebra steps. We need common denominator. Common denominator is a product of x minus 1 times x plus 2. And for the first fraction, quantity 2, I will multiply by x plus 2. For the second fraction, quantity 1, I will multiply by x minus 1. Okay? It's kind of like cross-multiplying, but it's not really, because cross-multiplying is for the equation. Okay, let's distribute numerator. I will switch my camera because then I can see the whole slide. 2x and 1x is 3x, 2 times 2 is 4, minus 1, it's positive 3. That's we have 3x plus 3. And one more step I can do, I will distribute everything what is in the denominator. Okay? X minus 1 times x plus 2. Okay, that means I receive something like that. Okay, and this is definitely a rational function, and it's not a simple rational function. Okay, okay, that means the whole point is to take this function, okay, and integrate. Okay? That means that's actually our point. What will be an integral of this? That's what you have to identify. You have to identify, okay, this is a rational function. And I do have a slide, I do have information about the proper and improper, but I can maybe tell you now, this is proper rational function because degree of the polynomial on the denominator, it's greater. Always denominator must hold a greater degree. Okay, that we can see degree in the denominator is second to the second degree polynomial, and numerator is the first degree. Okay, that means if the numerator has lower degree or denominator has a greater degree, that's the same, that's the proper rational function. Okay, that we do have a proper rational function, and how can we integrate? That means you have to know that this is rational function, proper rational function, and we have to rewrite this function as an addition or subtraction, depends on the smaller fraction, smaller, which we will call partial fraction. Smaller rational function, which means we have to know how to reverse this process that I just did. That means having this, okay, I have to get that form. Because now let's see, okay, of course, I'm just copying because I know that they are equivalent, okay, because I did the process and I know that this rational function is equal to addition of these two simple ones. And let's look at this one. This one is so easy to integrate. It's just constant 2 and ln of quantity from the denominator, x minus 1, plus 1 ln of the denominator, x plus 2. Okay, that we can see that's the point. That's the whole point, to rewrite the, I can say, a complex rational function to the partial fraction decomposition. Okay? But of course, you can probably think, how can I get this? That means, first of all, having this rational function, we're looking at the denominator. And if we can factor out, like this one, we have to do it. Oh, somebody has to switch off the video. Okay, because we're looking at, okay. Again, denominator, and we will factor out. And you can see we do have factors.
However, as far as that goes, that's going to be
Davey, switch off your video and mute your microphone. Oh, what's happened? Hello, can you hear me? Okay, because I thought that something happened. Okay, now everything works. Okay, let's come back. That means we do have two factors, x minus 1, x plus 2, and they are linear factors. That means you can probably think, okay, having x minus 1 and x plus 2, this will give me two partial fractions. That means this is my first step, going backwards, and then we will try to set up, okay, this will be my first fraction, this will be my second fraction. The only thing is we have to find out these quantities, 2 and 1. And let's see how we can do it. Okay, that's me. Let's take this one. This one is a little bit different, but it's proper rational function because denominator is winning with respect to the degree of the polynomial. And let's see. Integral of x minus 7 over x squared minus 6x plus 5. That means it's rational function. Let's try to factor out denominator. That means I think that's the factors, x minus 1 and x minus 1, x minus 1 and 5. Let's check. Negative 1 times negative 5 is positive 5, and when I add them together is negative 6. Okay, that means x minus 1 and x minus 5 are giving me my denominators of the partial fraction. Okay? But I still have my quantities a and b, right? And we have to find out. Oh, okay, I didn't type, let me write down. That means what we will do, we still have to remember that all of the three parts, all of the three functions, they look different, but they are the same, they are equivalent. That means if I will use my partial fractions, let's say a over x minus 1, b over x minus 5, okay? I can still try having this a and b, I'm still trying to get possibly the common denominator. That means the common denominator is x minus 1, x minus 5 times, and a must be multiplied by x minus 5, right? And b must be multiplied by x minus 1. Okay, that means now I know that this function is equivalent, and I can copy the middle one. X minus 1 times x minus 5, and on the top I have x minus 7. That means what we will do, we can see denominators are the same, then numerators also, they have to be the same. That means x minus 7 is exactly the same like a times x minus 5, b times x minus 1. That means this is my equation. And what I will do, I have to find a and b. I will pick a quantity for x, and let's say 1. And I will substitute to this equation, okay, and try to solve for a or b possibly. That means 1 minus 7 is equal to a 1 minus 5, b 1 minus 1. I'm just trying to put 1 in different color. Okay, and what I see, 1 minus 1, 0. 0 times b, 0. That means this is gone. What I'm getting negative 6. It's equal to negative 4a. Okay, that means a is 3 over 2, 3/2. Great, I did a. Okay, now I can do exactly the same, and I can pick different value for x, possibly 5. And let's substitute. 5 minus 7, okay, a, 5 minus 5, b, 5 minus 1. I will put back 5 minus 5, 5 minus 1. And let's see what we got. 5 minus 7 is negative 2. That's 0, that's gone. And 5 minus 1 is 4, 4b. b is negative 1/2. Okay, that means that's the way to get the coefficients a and b. Now I can come back. Let me divide the slides. That means I have integral of 3/2 over x minus 1 dx minus 1/2 over x minus 5. Oh, I was trying to split for 2 integrals, but we don't really have to. We can keep it as a 1. Okay, that means the first integral is just constant, 3/2, and natural log of denominator. Constant, natural log of the denominator, plus the constant of integration c. Okay, that means this is my answer of my integral of rational function. And as we can see, we do have partial fraction, we did recover coefficient a and b, and we have the integration. Okay, that means that's the way to solve. Of course, this is one type of the rational functions, and we do have 3 different types. That means let me solve the other one too. Okay, let's see. Okay, that means this is my slide telling, like, explaining proper and improper, but I think by now you should be fine. That we do have this complicated formula, but it's just the definition of the rational function. As mentioned before, rational function is the ratio of 2 polynomials. That we do have x to the power of m, x to the power of m minus 1, because always the degree is decreasing, and this is n minus 1, n minus 2, and so on. And if the denominator is winning, degree of the denominator is winning, is always proper fraction, proper rational function. If the numerator is winning, is improper. Okay? And what we will do, because we always, in order to get the partial fraction, we have to have proper rational function. But let's solve, maybe, before I start introducing another types, let's solve one improper rational function. I mean an integral. Okay, that's me. Let's see this one, because we also have to know what to do in this case. X cubed plus x over x minus 1 dx. That means this is definitely improper, because denominator is not winning. In this case, we have to divide polynomials, and we have to get this whole part. Okay, that's when we will divide the polynomials. Like, let's say the numbers. If I will have, let's say 14 over maybe 3. Okay? Of course, this is improper fraction. Okay? That's what I need. I need to divide how many times 3 go to 14. Can you tell me how many times I can squeeze quantity 3 in 14? 4. And then what's left? 3 times 4 is 12, 2 over 3. Right? That means that's the point. We have to, improper fraction, we have to rewrite as a mixed number, the whole part plus the remainder. Dividing by 3 because 2 is the remainder and I can't divide. That means the same thing I have to do with the polynomials. We have to know how to divide polynomials. Okay, that means I will copy polynomial from the top, x cubed, 0x squared because we're missing x squared plus x. And I will divide by x minus 1. And hopefully we remember x cubed divided by x is x squared. And then I am multiplying back x squared times x times x squared times negative 1. X squared times x is x cubed. X squared times negative 1 is negative x squared. But I will be subtracting. I'm changing the sign. This is gone. 0x squared plus 1x squared is x squared. And I'm copying. I'm putting down x. And I think I can divide again. X squared divided by x is just x. X times x is x squared, and I will be subtracting. X times negative 1 is negative x, but I will be subtracting. I'm changing the sign for the opposite. That's 0, x plus x, 2x. And again, 2x divided by x, it's 2. 2 times x is 2x. 2 times negative 1 is negative 2, but I will be subtracting. 2 is the remainder. Okay, that means my improper rational function will be rewrite as a whole part, which is the quotient. It's this part. X squared plus x plus 2 and plus 2 over x minus 1. I can't divide by 2 by x minus 1. Dx. Okay. And now I actually believe that we can integrate, because sometimes this fraction is another like a proper fraction, proper rational function, and we have to do the partial fraction. But this one is just a simple fraction which we know the antiderivative. Okay, antiderivative for x squared is x cubed over 3. Integral of x is x squared over 2. Integral of 2 is just 2x, and integral of this is the constant 2, and ln of the denominator. Okay. But of course, the point on this one is to identify improper rational function and change the whole part and the proper one. Okay, let's start dealing with the proper. Okay. That means having a proper a rational function. As I mentioned, we will focus on the denominator, okay? And we will try to factor out. And sometimes we will get all of the factors, linear factors, but sometimes we will get irreducible quadratic factors, because we know sometimes we can't factor out. Okay? And then let's see what we will do. Case 1, that's what we just did. Looking at the denominator and factoring out, we can get all different linear factors, distinct linear factors. That means you will be able to factor them out. Each of them is different, that we're not repeating them, and none of them is like identical. It's not the constant multiple of another one. Okay? That we can possibly do one more like that. And of course, then we will end up having all of these factors and then the constant. I think I will use the constant a, b, and so on. Let's say z. Okay, that means, let's look at this one. Integral of 5x minus 1 over x squared minus x. That means, can you quickly type the answer for my question? Is this proper rational function or improper rational function? Can I focus on my denominator and factor out? Proper. Okay, thank you. It is proper, because of course denominator is greater. Okay, that means if it's proper, don't worry for the long division, simply focusing on the denominator. Did I type this? Okay, I didn't type. Okay, that means the first step is to factor out denominator. X squared minus x, I think I can factor out just x. Okay, and I see x and x minus 1. That means I see x and x minus 1. I see two linear factors, they are different. Good, that means this is my case 1. And what I will do, I have to find a and I have to find the coefficient b. Because that's definitely the maximum number of partial fractions, because I can't have additional fractions, because x times x minus 1 will give me the same denominator, and that's my original function. Okay. And sometimes what we can do, we can simply, like, we even know what will be the integral. The integral of a over x is simply a ln of x. I still have to find a, of course. And this one will be b ln of x minus 1. Okay? But let's find out a and b. That's what we will do. I will copy numerator only. 5x minus 1, we can see that's the original one. And now, looking at my partial fraction decomposition, if I will combine them together, I will have denominator x times x minus 1, which is the same, and my numerator, including a and b, will be like that. A, I will multiply by x minus 1, b, I will multiply by x. A by x minus 1, b times x. Okay, that means this is my equation to work out and get coefficient a and b. Okay, let's pick the x value. I will pick 0, and if you substitute 0, we will get 0. 5 times 0 is 0, minus 1, a, 0 minus 1, b times 0. Of course, this is gone. This is negative, 0 minus 1 is negative 1, and a is 1. Excellent. And then let's pick another value. Let's pick 1. And I will substitute 1. 1 times 5 is 5, minus 1 is 4. A times 1 minus 1, b times 1. This is 0, and this is b, okay? B is 4. That means we do have 1, and we have 4. I can copy one more time. Ln of x plus 4, ln of x minus 1. And that we can see, that's the nice way. One more thing, I can just rewrite, because we never know for the multiple choice, I can put that 4 as an exponent. X minus 1 to the power of 4. And now, since I am adding the same logarithm, I can multiply. I can multiply x times x minus 1 to the power of 4, because multiplying means that we were adding two logarithms, two logarithmic functions. But still this answer is a good answer, just in case, if you will see on the option. And let's divide the slide for two different works. Okay, that's the way to get the partial fraction decomposition. Okay, let's see. I think I have another one. Okay, this one is a little bit longer. I will not solve it, but let's just do the partial fraction decomposition. Okay, let's help me if I can split out for my partial fractions. And again, the first question, is this proper rational function? It is proper. Yes, thank you. Now, what do you think? Yes, thank you. What do you think? How many partial fraction are we gonna get? How many partial fraction? Yes, because degree, thank you, 3. Because degree of the denominator is 3. That means probably we will get 3. Let's see. I will copy, but I don't want to take your time, and you know the process, you know the concept. That means you will try to work it out. Okay, the only thing for now that I can do, I can factor out x. 2x squared plus 3x minus 2. Quadratic function. Let's do x squared plus 2x minus 1. And now I have to factor out the quadratic expression, 2x squared plus 3x minus 2. It's not, I mean, it's probably easy for some of us, but for some of us could be challenged since the leading coefficient is not 1. But I will put 2x and I will put x. And then 2. 2, the factors of 2 is 2 and 1. That means I will put 2 times 1. 2x times 2 will give me 4x, and subtracting 1x, I will have 3x. Okay, that's we can see x, 2x minus 1, x plus 2. And my partial fractions are x, 2x minus 1, and x plus 2. And A, B, C. Because all of them are the linear factors, x, 2x, x, we can see. Then I have to put just the constant, A, B, and C. Okay, and we know the process. Okay, it's 3, that means a little bit longer, but it's the same idea. Okay, that means I will leave it this one for you. At least we have the partial fractions. Okay, let's see. Oh yeah, I do have the answer. You can probably, yeah, you see the values of A and B and C. Let's see, but you will do it. Okay, now, oh, let's don't look at this one for now. Okay, let's do one more before I introduce the case 2. 1 over x squared minus 9. And that means this one is nice and easy rational function. Of course, it's a proper rational function. We can easily factor out, and we do have x minus 3, and we have x plus 3. Of course, A and B. Okay, and let's see. My numerator is 1. Okay, and then looking at my partial fraction, if I will get the common denominator and my numerator will be A multiplied by x plus 3. Okay, and B will be multiplied by x minus 3. Okay, and I need A and B. I will substitute instead of x 3. And I will have 1, 3 plus 3, 6a, and this is 0. That means a is 1 over 6. And then let's substitute instead of, actually, can you tell me, because I still didn't mention, what will be my second choice for x? Yes, okay, that's you probably did figure out where my numbers come from. Okay, I didn't mention this before because of course I wanted to ask you, I always pick the zeros of the denominator. You probably realize, right? The zeros, the zeros of the factors. That means 3 and negative 3 will give me 0. In the previous one, I also picked the zeros. Okay, 1, a negative 3 and positive 3 is 0, and negative 3 and negative 3 is negative 6b. That means b is negative 1 over 6. Oh, I use, oh, no, let me use the red color. Okay, and you can probably see negative 6b. Okay, and let's integrate. This will be a Oh, I can put my values because previously I didn't have the values. 1 over 6, x minus 3, negative 1 over 6, x plus 3. Okay, and then 1 over 6 ln of x minus 3 minus 1 over 6 ln of x plus 3, plus the constant of integration. Okay, that means this is, we can still factor out. Let me do one more thing for you and I will make few comments. I'm just factoring out 1 over 6, the coefficient. And now I can rewrite as a 1 logarithm because I'm subtracting, then x minus 3 and x plus 3, I can divide. That means just in case you may see this form. This is still correct, but this is also the same. Okay, but one thing you may notice, I don't know, maybe this is too tiny or maybe not. Can you see my general formula in the corner? This is 9. You can see x squared minus 9. And the answer is ln of x minus 3 minus x plus 3, of course, because that's the partial fraction, the denominators, but the coefficient in front is 1 over 6. Okay, that means 9, we can rewrite as a 3 squared. And 6 is simply 2 times 3. Okay, that means having this quantity, having the formula, 1 over x squared minus a squared, you can still do the partial fraction. We can see it's not a problem. But you may also remember that the integral will be simply ln of x minus a, okay, minus ln of x plus a. A, of course, is then the a squared. In this case, is 3. And the coefficient in front will be 1 over double the a. And that's me, I know that some of us like this. I will still take time and use the partial fraction decomposition. But I know that some of us like this one. Let me try. What will be the integral of the rational function x squared minus 25? Do you think you can tell me based on the formula? First of all, what's the quantity a? In this blue example, what's the quantity a? The a, can you see what is a? A is 5, yes, thank you, guys. That's because this is 5 squared. Okay, that means looking at, possibly we can use that form. Looking at this form, instead of 1 over 6, what coefficient we will have? What coefficient we will have? This was 1 over 6. We can see it's 1 over 2a. 1 over 10, thank you. 1 over 10. And then ln, absolute value. And what shall I put on the top of this fraction? Can you see x minus 5? X minus 5, thank you. And in the denominator, respectively, who can type for me? X plus 5. And now if you all follow. Okay. As you can see, just here, just in case if you don't like spending time and you like to remember the formulas, you may remember. But of course, the whole process is important too. Okay, good. That's when we do understand the formula. I can maybe write as a value. Okay, let's move on. That means you're definitely good with case 1. Okay, now the case 2. That means what we will have. Case 2, yes, case 2 is nice and sometimes funny. Okay, the same thing. Rational function, proper rational function, focusing on the denominator, trying to factor out. And we will have all of the linear factors, but some of them will be the same, will be repeated. Okay, that's what we have to do. That means let's even look at this rational function. I just gave you like an example. But we have something x cubed minus x plus 1 on the top. In the denominator, we actually have the factored form. We have x squared and x minus 1 cubed. Can you tell me the degree of the denominator? What's the degree of the polynomial from the denominator? What will be the degree from here? Because I'm still, oh no, 5, because we're adding 2 and 3. Thank you, Dalis, and Calvin. Oh, and Shivandi, I don't know if I'm pronouncing. Yes, we have to add, because if I will expand everything, I will have x to the power of 5. That means we definitely good. It's a proper rational function. Okay, and now what we have to do, we have to think that x squared is actually x times x. Okay, x minus 1 to the power of 3 is x minus 1 times x minus 1 times x minus 1. That means you can see the degree is 5, and we have to see the 5 partial fractions. And we can see A, B, C, D, E, 5 of them. What this means, we have to include every single component. If I have x times x, I have to include x, and I have to include x squared. Because the common denominator of this is x squared. Maybe a will be 0, I don't know, and maybe I will not have this part, but I have to check. Because the common denominator, of course, if I have x squared, that's x squared. But having also x, both of them is giving me common denominator x squared. That's when I have to include every single fraction. Okay, and the same for x cubed. I mean x minus 1 cube, the same thing. Because I might not have this, because that's what probably everybody likes to do. Just put the partial fraction, this one and this one. And makes sense because this is giving me the common denominator, but the smaller multiple of x minus 1 cube, it's also part of the partial fractions decomposition. And that means I have to include everything. X squared, and then x minus 1 to the power of 1, x minus 1 to the power of 2, x minus 1 to the power of 3. Okay, and let's pretend, okay, whatever on the top. Like let's say x to the power of 5, x minus 1 to the power of 2. How many partial fractions we will have for this one? We will have 7, thank you. That means I have to include like x, and then x to the power of 2, x to the power of 3, x to the power of 4, x to the power of 5. Because we can see the common denominator for all of them is x to the power of 5. And of course, x minus 1 squared. A, B, C, D. Do I know my alphabet? I think I know. Okay, that's when we can see that's the idea. We can't just take x to the power of 5 and x minus 1 squared. No, we have to have all of them, just in case. As I said, some of them could be 0, but we have to get the zeros. We don't know. Okay, that means that's the difficult part of the case too. Let's see, let's solve some of them. Oh yeah, I have some more fractions, but you can look at this. Yeah, I'm trying to show you that we may have this denominator. Let's see, this denominator and the same denominator. Yeah, let's look backwards. And I might have, because degree of this denominator is 3. Okay, and I might have all of the 3 partial fractions, but I also might have 2 of them. Depends. Everything depends what is on the top. Everything depends on the numerator and the way our work for coefficients A, B, C, or more. Okay, that's we can see we have to include. That means the top line it's showing me that each of these partial fractions stays and gave me the value on the top. Okay, just a clarification. Okay, I don't know. This is probably too long. Okay, let's actually solve it because it's the only one that I have. Probably it's long, but let's see. You will help me because will be lots of algebra. Okay, let's see. We have rational function. You can probably read the function. Can you tell me if this is proper rational function? It is proper? Yes, it's proper. Now the question is, what's the degree of the denominator? What's the degree of the polynomial 4? Okay, because it's x squared and another x squared. Good. That's we're expecting 4 partial fractions. Okay, let's see. I have x squared. That means I will have x and x squared. And x minus 1 squared, which is x minus 1 squared. Oh, too long, but let's do it. A, B, C, and D. Okay, that's me now, because see, I did skip one of them, which was 3, but I will not skip this one. That's me now. We have to think like backwards, okay? I will try to combine everything, and I will try to get the common denominator, which of course, the common denominator is this, x squared, x minus 1 squared. But I still have to look at my partial fractions, including A, B, and C, and D, and get the common denominator. That means the top, which is the numerator, 3x cubed plus x squared minus 8x plus 3, must be the same like the numerator on the right-hand side. Okay, let's focus. Quantity A, like underneath, yes, you can see we have only x, and the common denominator is x squared and x minus 1 squared. That means the coefficient A are missing 1x, because 1x is there, and it's missing x minus 1 squared. Okay. The coefficient B, underneath the coefficient B, already have x squared. That means I do have x squared. The only thing that is missing for the common denominator will be x minus 1 squared. Okay. The coefficient C has x minus 1, but we need x minus 1 squared. And doesn't have x squared. That means I will multiply by x squared and x minus 1. And then coefficient D has x minus 1 squared and is missing just x squared. Okay, long process. Okay, what we can do? Okay, let's actually do it. I will pick the quantity 0, because that's the 0. And let's see, 0, 0, 0, I will have 3 on the left-hand side. A times 0 gone, D and C will be gone. A, C, and D will be gone. B will be not gone, because I will put 0 minus 1 squared, which is 1, it's just 1. Okay, that means B is 3. I will not. Actually, I don't like this way, of course. I'm trying to save space. Okay, B is 3. Okay, now, okay, what value shall I pick for x? Who can tell me now? X is equal to what number? 1. Thank you, thank you. And you probably see that we're actually approaching a small problem, but let's see, 1. Okay, check my arithmetic. 1 plus 1, 4, minus 8, negative 4, plus 3, negative 1, because I don't want to make mistake. 4, 7, 8, negative 1. Okay. Now, A will be gone because it's 1 minus 1. B will be gone, 1 minus 1. C will be gone, 1 minus 1. D. D is a D, not a B. D. 1, that means D is E. Now I'm writing B. D is negative 1. Don't stop writing. Okay, but now we still have coefficient A and C. Okay, that's what do you think? What value for x shall I get? Because this is the problem. The case 2 has more fraction than the zeros because they are repeating. We can see x is repeating and x minus 1 is repeating. Okay, that's mean what we can do from now. We can actually pick any value. The only thing is we will be not able to cancel out right away. That means probably we will end up with the system of two equations, but it's still fine. Okay, that means for now I will pick maybe 2. Okay, I will pick 2. 2 cubed is 8. 8 times 3 is 24 plus 4 minus 8 times 2, 16 plus 3. We can see lots of arithmetic. Okay, 2. 2a and 2 minus 1 is 1. Okay, that means it's just 2a. 2 minus 1 is 1, that means it's b. 2 minus 1 is 1, but 2 squared is 4. 4c and 4d. Okay. 20, this is 28. Let me write this way. 28 minus 13, if I can do this way. 2a, b is actually 3. I can put 3. C, we don't have a C, and D is negative 1, negative 4. Okay, this is 15. Please check my arithmetic, because doing arithmetic in front of the students is the most difficult part. And I did work this integral, but I don't have the solution in front of me. Okay, let's see. 2a plus 4c and 3 minus 4 is negative 1. And if I add 1 to both sides, I will have 16. Okay, not bad. Let's divide everything by 2. 8. A plus 2c. That means just what I said. We don't have the value right away, but we have the relation between A and C. And then we will pick another one. I can pick, what value I can pick? Let me actually make a little bit. I will pick maybe negative 1, because negative 1 was not chosen. Okay. Watch, I'm substituting to the left-hand side, okay? Negative 1 will give me negative 3, positive 1, negative 8 and negative 1 is positive 8, plus 3. Oh, I need longer line. Okay, I will try to squeeze it. Okay, negative 1 and negative 1 is negative 2, but squared will be 4, but still negative. Negative 4a. Negative 1, negative 1 is negative 2, 4. 4b. Negative 1 and negative 1 is negative 2, and this is positive. That means this is negative 2c, and this will be plus d. Okay, I have 9, negative 4a, b is 3. 3 times 4 is 12. C, we don't have a C, negative 2c, and D is negative 1. 12 minus 1 is 11. When I subtract 11 from both sides, I will have negative 2. Okay, let's divide. Actually, let's do not divide by 2, because we will solve this system of two equations, but by elimination. Oh, I have to save space. That means let's do this way. Negative 2, negative 4a, negative 2c, and I will put 8a plus 2c. And we can see the opposite coefficients. I will add them together. This is gone. This is negative 3a, and this is 6. Ah, okay, a is negative 2. I like this. And if a is negative 2, we can work it out. C will be, if a is negative 2, I will put negative 2. Who can compute C for me? Probably it's not a difficult. 10, 5. Who can compute? Can you just put negative 2 to this line? I think it's 5, but I would like to see your confirmation. 10 divided by 2, 5. Okay, I'm trusting you. I mean, because it's not easy to see. Okay, that we do have all of the coefficients. We can see a little bit. I can definitely tell you this is perfect example for the practice, for homework assignment, but not for the test, not for the exam, because it's too long. I still want you to know the process, okay, of finding this, and especially this line. That's how I got the right-hand side of the blue box. Okay, and the rest of them is just substituting and getting these numbers. Okay, but what we need to put the fraction. Okay, what is A? A is -2, 3, 5, and -1. Let me, do I have a slide? I don't have the slide because case 3. Let me add a slide. Okay, and we will just finish the integration. Okay, that means the integral is a over x plus b over x squared c over x minus 1 and d over x minus 1 squared, because we have one more thing. Okay, what was a? I think it was -2x. B is x squared, I mean 3, C is 5, and D is -1. I can put subtraction. Okay, and now you can help me. This is probably not a problem. -2 ln of x. Nice and easy. This one is not a problem. 5 ln of x minus 1. But now, do you remember what will be the integral of these two? Of course, the coefficient 3, the constant 3, I can copy. What's the integral of 1 over x squared? And it's the same, 1 over x minus 1 squared. Do you remember? Because it's, please remember, do not put ln of x squared, because that's different. Integral of 1 over x squared. Yes, thank you. I can put this -1 over x, and this one will be exactly the same, but x minus 1. Okay, let me finish. This is x to the -2, and -2 plus 1, -2 plus 1. But of course, we know right away. Oh my gosh, I'm taking all of this space. Yes, that means this is an integral of 1 over x squared. That means for the case 2, since we're squaring denominator, please remember about this. Okay, that means the final answer will be -2 ln of x minus 3 over x, addition, 5 ln of x minus 1, and negative will give me positive. And plus the, oh no, this is minus, plus the constant. Oh my gosh, really nice integral. Lots of different components. But please note this one, as soon as it's squared, it's not ln. It's easy to make this mistake. We do have an integral on this side. Oh, Kyrie, what are you asking? Negative, oh, thank you. Not -3 over 3, -3 over x. Yes, thank you, thank you. Oh, no, you're watching. That means it's, for you, it's easier to pick it up. I'm just right, but yes, thank you. Yeah. Okay, that's me. Now, let's look at case 3. Case 3, what we will have? Again, proper rational function, looking at the denominator, trying to factor out. And we will factor out, but not all of the factors will be the linear, okay? We will have quadratic factors which we can't reduce further, which we will call irreducible. For example, something like that. Okay, let's look at this function, x on the top, and then x minus 1, nice and easy linear factor. x squared plus 1. We can't factor out x squared plus 1. And the same x squared plus 4. Okay, but we have one thing. You can probably see, but I can repeat one more time. We're gonna have 3 fractions because we do have 3 factors. X minus 1, x squared plus 1, and x squared plus 4. Right? I can box this. I'm just repeating my last line. Okay, this one is linear, x minus 2. No problem. We will have coefficient a. But now we have one more thing different. Since this is the quadratic expression, I can't put just the constant like b and c. I have to put the full linear term, which will be like mx plus b, theoretically saying. But I have to keep my letters in order. That means I will put bx plus c, and the same for this one. This one is quadratic, irreducible. I have to see like just the function, just the polynomial 1 degree less, which is the linear one, dx plus e. That means, please remember, we just can't put a, b, and c. We can do for case 1 and for case 2, but for the case 3, if the factors are quadratic irreducible, we have to put degree 1. And even we can see the logic, because even looking at the first fraction, degree is 1, and degree of a is 0. That means the difference is 1. Degree on the denominator is 2. That means the difference is 1. I have to put the full first degree, the linear term. Okay, that means this is the difference. Okay, and let's solve this integral. 2x squared minus x plus 4, x cubed plus 4x. It's definitely proper because it's cube versus squared. Okay, and let's focus on the denominator and let's factor out. 2x squared minus x plus 4. I can factor out x, and I have x squared plus 4. Okay. I will save space. And we can see even if the degree is 3, we will not get 3 partial fractions because we can't reduce one of them. Okay, that means I will have 2 partial fractions. A, and now I can't just put b, I have to put bx plus c. Okay. And the same process. Numerator, original one is 2x squared minus x plus 4. Now, getting the common denominator and the quantity on the top, I will have a multiplied by x squared plus 4 and bx plus c multiplied by x. A multiplied by x squared plus 4 and bx plus c multiplied by x. And let's repeat the same process. Let's substitute 0. And actually, the 0 is the only 0 from the denominator. Okay, that means I have to pick, and I have a, b, and c. I will pick 2 different values. Okay, substituting 0, I'm getting 4 on the left, 0 for a. A is 1. Nice and easy, but that's, I am afraid it's end of my zeros. Okay, what do you think? Can you suggest a number for me instead of x? What shall I substitute? Probably yes, 1. Probably the easiest one, of course. Always, you can always pick 1, negative 1, 2, negative 2, of course, of course. Okay, 1, 1, 5. Please check. 2 minus 1 plus 4. And then 1 will give me 5a and will give me b plus c, which actually 5, I mean a is 1, that means this will be, oh, not bad. B is equal to negative c. I like this. And then let's substitute. Okay, what do you think? Negative 1 or 2? What will be easier? I would like to see your opinion. Shall I pick, because I need another value, because I need another relation? I have 0 and 1, 1, yes, I think -1, yes. Just, I mean, with the negative numbers, we have to be really careful because it's easy to lose that negative, but yes, I will do -1. Okay, watch my arithmetic. -1 squared is +1, 2, +1 plus 4, 7, and then this is still 5a. Negative times negative will be -b, and negative is positive, and -c. Okay, plus b minus c. That's mean what I can do too is b minus c. But instead of b, I can put -c. That's mean -2c is 2, c is -1. That means if c is -1, b must be opposite. Okay, excellent. Now let's see, because we still have things to integrate. 1 over x plus x minus 1 over x squared plus 4. Okay, ln of x, that's easy. Okay, but now we do have this integral. Of course, denominator is kind of like challenging us. But please tell me, do you recognize this denominator like x squared plus 4? What kind of formula we will definitely see at some point? X squared plus 4, quantity squared plus a number. What formula holds this? I mean, what antiderivative, what integral holds this type of denominator? Do you remember? Section 6.6? Or I think even today on my first slide? No? Inverse tangent? Yes, somebody right, Kylie, what did you tangent? Yeah, inverse tangent. Okay, but what I will do, first of all, I will split for 2 integrals. Because inverse tangent, I can use this only if I have no x on the top. That means the second integral looks like that. Okay? That means, can you see what I did? I had x minus 1 and I split for x minus 1. Okay, and now this one, how would you integrate this? What techniques you will use for this integral? X over x squared plus 4. What is the best way to get the answer? Oh, they use yes. Oh, I shouldn't say. Okay, but you were probably typing before me. Yes, they use substitution. That's we can definitely try u substitution. Du is 2x dx. 1/2 du is x dx. That means I can possibly split that for 2 integrals. Minus an integral. Okay. I just want to remove that. Okay. That means we will have 1/2 integral of 1 over u du, because that means ln of u, but u is x squared plus 4. ln of x. Okay, great. I did squeeze the u substitution. I don't have to repeat multiple times. No. That's this one. And this is this one. Okay, and now this one. I don't know if you remember, because if this will be x squared plus 1, this will be simply inverse tangent. But since we adding 4, we will have half inverse tangent x half. Okay, because that quantity 4, which is 2 squared, is giving me this. If you will use the u substitution, you will definitely get that one. And that means, please remember, if this is 4, which is 2 squared, we will have 1/2 x over 2. If this will be 9, 1 over 3, x over 3. If this will be 16, 1 over 4, x over 4. But still inverse tangent, the main formula. Okay, that's mean, I think this is my final answer. Yeah, it's quite challenge. And this one is, this one is not bad. This one is not long, because you can see the algebra part is quite, the arithmetic even, it's quite fast. And if you're not doing for somebody like I did for you, probably you will be much, much faster than me, and you will integrate easily. That means this could be the quiz question or the exam question. Okay. Could you go through, okay, the last one. I think we did solve it, but no problem. What I have, okay, okay, let me add a, just in case if I will need, and go through. Come on, my laptop is slow. We can solve this one. That means this, hang on. Okay. 1 over x squared. Okay, this one. This one, I believe everyone knows that. Is that correct? Are you okay with this one? X squared plus 4. Okay, that means what I have. Yes, I really have to see, I have 1 and I have 4. That means I will factor out that 4 and I will get x squared over 4 plus 1, which this is 1/4. And now I will see x squared over 4 is actually x over 2 squared. Okay, now we can nicely see. Okay, I factor out 4. Now I put 1/4 outside, and x squared over 4, it's the whole quantity x over 2 squared. And now the u substitution. I will let u to be x over 2. Du is just half dx. 2 du is dx. Perfect. We did have 1/4. Now I have 2 du, that's my dx, and 1 over u squared plus 1. Right? U squared plus 1. 1/4 times 2 is 1/2, and integral of u squared plus 1 is on the top. Inverse tangent of u. But of course, u is, not ln, u is x over 2. Okay, that's the way to solve it. But again, if you like the formulas, I can write down integral of x squared plus a squared. It's 1 over a inverse tan x over a. Just in case if you will like. But this is the workout, yes, of taking care of that 4, of that a squared, 2 squared. And we can see 4, 1/2 x over 2. If this will be 9, 1 over 3 x over 3. If this will be 25, 1 over 5 x over 5. But the u substitution is showing us. Okay, I hope this makes sense. Okay. Yes, okay, no problem. I know it's lots of integrals. You probably realize I did open the midterm module, which is the week 4, and I did add like a list of integrals, which I think it's even on the main website of Math 140. And I did solve for you. That means I will really recommend to go all of these integrals, just to be confident, because the whole, almost half of the test is like integration. Okay, That means that's all of my integrals. And as I promised, I should solve, let's solve maybe one integral from trigonometric substitution. Or maybe I can solve later and put it for you because I don't want to hold you. Do you think do you want me to solve one more trigonometric substitution? Or it's too late for you? I can still solve on my own and put the video for you. Oh, come on, be brave and answer. I try to get, where is my slide? Oh no, secant cube, no, we're not asking for secant cube. Where did you get this? No, we're not even asking for, I think was this one. We will not even ask you secant, okay? No, secant cube. Oh, did he really integrate secant cube? I'm fine with it now. If you, oh, I do have a time and I can solve this one for you. Okay, no. Okay, I can promise you, we will not ask what's the integral of secant cube and ask you what's the integral of secant. I will let you know. Because sometimes we ask, but even integrating secant, it's funny. But oh, secant cube, it's the integration by parts, and it's no. You can still try it, I mean, as a practice, because it's lots of different nice parts, which I still like you to be like confident, but we will not ask you on the test. It's too long. And yes, secant is yes. Secant, if you remember, yes, I didn't want to write the formula. I think I did write in my section 7.2. It's natural log of secant plus tangent. Yes, I do remember this. This one I don't even remember. Secant, it's also natural log and it's plus something. No. We will not ask secant cube. I mean, I can do it, secant cube. I can go through, but it's too long. Okay, that's me. No. Even this one. Yeah, like how we got this answer. If you see, I think your textbook is solving these problems. No, that's too much. I mean, it's nice for the teaching, for the learning, for practice, but not as a test question. Okay, let's see. Okay, do you think can we solve this integral? Because somebody asked, I think this is one of from the discussion, which is, it's from the last section, 7.3. Okay, that means I will erase this. And let's see. You see the integral is x cubed over square root of x squared plus 4. That means, what do you think? It's definitely trigonometric substitution, but do you remember something from yesterday? What will be the appropriate substitution for me to use, to apply now? Two tangents, yes. Because first of all, we remember, we have to look at the square root. If we see the square root, that's good, that's probably the trig substitution. And then the quantity x squared plus 4, or maybe 4 minus x squared, or 4 could be different. Or, what's the other one? We have 4 minus x squared, we have x squared plus 4, and then we have the other one. Oh, we have sine, tangent, and secant. This one is definitely tangent, both positive. And we may have 4 minus x. Let me write this one. We may have this one. Okay, and we may have this one. Okay. That means you will see this type of square root, which is actually now is the case. We will let x to be 2 tangent theta. What about the second one? Of course, it's not. I'm just trying to give you the whole. I mean, all of the cases. What substitution you will do for the second one? You can tell me which function you will pick. each of them will hold the coefficient 2. It's obvious. Yes, for the second one is sine theta, really good. And for the last one is, it's secant. Okay, this is kind of like a diagram. And everything is based on the formulas, right? Because we remember tangent square theta plus 1 is secant square theta. 1 minus sine square theta is cosine square theta. And the last one is, we have to, it's the first one, but it's the other way, secant minus 1 is tangent. Okay? That means that's the corresponding trigonometric identities. And having the expanded form, we can see, having the expanded form like this one, we can nicely simplify, because that's the point. I can't simplify this, but I can definitely simplify this one. Will be just secant because domain is letting me to do it. This will be just cosine and this is just tangent. Okay, that's the whole point. Okay, let's focus on our integral. I took the space, but I can possibly use my second slide. Okay, that's me. I will let x one more time to be 2 tan theta. Dx will be 2, and the derivative of tangent is secant square theta d theta. Okay, and let's go here. That's me. Now let's substitute. X cubed will be 2 cubed tan cubed theta. X squared will be 4 tan square theta plus 4. And dx is 2 secant square theta d theta. Excellent. And let me just, because I don't want you to be confused, this is just the theoretical part. Okay, and we can simplify things. Of course, the point is to simplify the denominator. That means I can maybe work it down here. 4. And I have tangent square theta plus 1. 4. And then tangent square theta plus 1, we can see is secant square. And this is just secant. I can rewrite my denominator like that. Okay, this is 8 and 2. I can write 16 tan cubed theta secant square theta d theta and 2 secant theta. Oh, my laptop is slowing down. Okay, this is gone. That's 8 secant and squared. Is that correct? Yep. And what we will have 8 tangent cube secant. Am I right? Let me use my, my laptop is, question. Where did the 2 go in front of the secant? This is 8, this is 16. Yeah, I should keep it for you. Can you see this is 8, this is times 2, I put 16. But I can keep 8, and I can keep 2, and I can cancel out. And the same thing, I just combine them together, which maybe I mean the same thing. Okay, 8, yeah, okay. That means we do have 8 tan cube and secant theta d theta. Let me double check. Okay, and do you remember section 7.2? How can we solve this one? I will pull out 1 tangent and 1 secant. That means this will stay squared. Secant theta, tangent theta, d theta. And this is the derivative of secant. That means the rest of the integrand I have to rewrite in terms of secant. Tangent square is secant square theta minus 1. And I can copy this. Maybe the session is too long. Oh, can you hear me? You're not answering. Yes, you can hear me because I'm getting really weird. No. Okay. Oh, now maybe I'm back. Oh, I think now I'm back. Okay. That means I will solve this one through the u substitution. I will let u to be secant theta. And du is ready in the box. Secant theta, tangent theta. Okay. And 8 u squared minus 1. And this is du. Integral of u, oh no, integral of u squared is u cubed over 3. Integral of 1 du is just u. And then we can substitute back hear me now? You probably, it's not, I don't even know why this is happening. It's always when the session is a little bit too, you can hear me now, probably, yes. Can I write? Oh, okay, I can write secant cubed theta over 3. Secant, no, it's not. Okay, the only thing is we have to get back the x expression. That means our x was 2 tangent theta. That means tangent theta, it's x over 2. Okay? And I can draw my triangle. If this is theta, tangent means opposite over adjacent, x over 2. That means if this is x, this is 2, using the Pythagorean theorem, this will be square root of x squared plus 4. And now from this triangle, I can read secant. And secant is the reciprocal of cosine. That means this will be square root over 2. Let me put 8. I will have x squared plus 4 square root of this over 2. That's my secant. Cube and still 1/3 and minus secant. X squared plus 4 square root over 2. Okay, I think I finished because we can definitely see, I can write it down. Secant theta is hypotenuse over adjacent. You can correct me if this is not right, but I believe it is. Okay, and I took this formula and substituted instead of secant. Okay, quite long integral, but really, really nice. Okay, okay, that means let's finish the session. If you still need me to solve some integrals, I can add like additional, tell me the integrals and I will like go through and I will make a video for you. Okay, I will explain step by step. But for today, let's stop integrating. Okay? But please, here remember, you have to integrate every day until the day of the test. Okay, then you will get confident. You will build your confidence. Okay, thank you and have a good night. I am back. Yes, yes. So we will need to solve case and to probably yes. Probably I will ask you for case 2 and 3, but quite short integrals.